So here we're looking at a concert hall planner who begins to time, looks at the number of cars in the parking lot, and as time passes, notice there are a different number of cars in the parking lot. So we want to find the average rate of change and explain the real-world meaning of this value. So we can say that as he begins, so initially at time 0, the number of cars is at its maximum, 53 based on the number of tickets sold. But 20 minutes later, as this concert ends, there are only 2,154 cars. Now the question is, what do we mean by rate of change? Because it doesn't really tell us what as a function of what. But really here he is looking at the number of cars as based on how much time passes by after the end of the concert. So the question is, would you rather see the units cars per minute, or do you think it makes more sense to talk about the minutes per car? Well, that doesn't seem to make sense. The cars depend on minutes, so we would probably want to measure how many cars per minute are leaving. So that means we need to figure out, well, how many cars are there? Well, it doesn't really matter what order you really subtract these in, but we know that the number of cars has gone down. Oops. 53 minus 2154, and we get that the number of cars has dropped by 3,199 cars, a decrease of that amount, over the course of 20 minutes. So there we go. There are units, cars per minute, and negative 3199 divided by 20 minutes will give us a decrease of about 160 cars per minute. Now we want to create a linear function that models the number of cars, we'll call that n, as a function of the time in minutes after the concert. So function of time. So in condensed notation we could write n of t, and in this case n of t equals, well, how do we figure that out? Well, we know that the initial value at the start was 53, and every minute that passes by we're reducing it by about 160 cars for every minute of time that passes by. So 53 minus 160t. After 25 minutes, we would expect the number of cars after 25 minutes to equal 53, the original, take away 160 cars per minute for 25 minutes, and we would get 53 minus 160 times 25, which gives us about 1,353 cars left in the parking lot.